Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap and hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. Galaxies collide with one another, and stars are born on the big cosmic stage, which is a place that is both mysterious and wonderful. This region is characterized by intense storms, the magnetic fields of the Earth are blocked, and the mysteries of the moons have the potential to alter our perspective on life. Our solar system is dominated by Jupiter, which is the largest and most protective planet. All of the other planets in our solar system might fit inside of it because it is so enormous. A day that lasts only 9 hours and 56 minutes as a result of a world that rotates at such a rapid rate that the surface becomes flat at its poles. Here, lightning is more powerful than anything else on the planet. This demonstrates that cyclones are subject to change throughout time because it is feasible for a single storm to encompass 2 or even 3 Earths. It is a well-known show that there is a mystery around it. They are getting closer and closer to solving the mysteries of Jupiter, but there is still a great deal that they do not know right now. What concealed secrets lie beneath its hazy exterior? Jupiter's moons might be the key to unlocking the door to life on other worlds. For our delicate planet, what does the dance of gravity that Jupiter performs mean? Jupiter, the 6th planet in our solar system, is home to more marvels than any other planet. Jupiter is 11 times wider than Earth, having a radius of 43,440 miles. Jupiter would be around the size of a basketball if Earth were a nickel in size. Its enormous footprint is heavier than every other planet put together by a factor of 2. Jupiter is magnificent not just because it is large and beautiful, but also because its construction is extremely intricate. Take Jupiter's magnetic field as an example. It defies our comprehension of planetary physics and remains a cosmic enigma. Jupiter has a magnetic field that varies shape in contrast to Earth's rather static field. It has changed in a few short decades according to recent studies. This trend is called secular variability. Because of its ever-changing magnetic field, Jupiter is very noticeable among the planets of our solar system. Zone winds are one possible explanation for this shift. A massive storm system stretches over 1,800 miles in depth. At this level, Jupiter's hydrogen acts similarly to Earth's cores molten iron in producing a magnetic field. A strange form is imparted to the magnetic field by these storms. An unseen concentration of magnetic fields known as the Great Blue Spot is located in Jupiter's southern hemisphere. When compared to the magnetic field of Earth, which is similar to that of a bar magnet, Jupiter's magnetic field is significantly more complex. After beginning in a broader band lower in that location, it completes 2 complete rotations in the southern hemisphere. The enormous pressure exerted by Jupiter brings about the formation of metallic hydrogen in the form of a liquid. The movement of this material is brought about by convection currents, which are brought about by fluctuations in temperature. It is precisely the electric currents that are generated by Jupiter's continuous rotation that are responsible for the formation of that magnetic field. The irregularity of the magnetic field can be explained by the fact that the nature of metallic hydrogen shifts as it moves deeper into the planet's interior. Layers with varied densities and conductivities come together to provide a magnetic environment that is both diverse and complex. The immense celestial display that is Jupiter's magnetic field goes far beyond its status as an intriguing scientific phenomenon. At the poles, the planet's strong magnetosphere puts on a spectacular light show called an aurora, which is evidence of the planet's magnetic might. Embracing the quest for knowledge unveils a world of intricate beauty and a profound sense of oneness with the cosmos. Closer to Jupiter's surface is where the planet's powerful magnetic field is created, making it significantly more powerful than Earth's. This gives us a plethora of data that can shed light on the nature of the magnetic fields on our own planet. Even with the largest planetary magnetic field, this gas giant has more records to its name. When it comes to the solar system, Jupiter is undoubtedly king. Its 92 moons and several satellites make it the most planetary monarch in the solar system. Jupiter's satellite system is adorned with the jewels Ganymede, Europa of Callisto, and Io discovered by Galileo. Ganymede possesses its very own magnetic field. It is the solar system's largest satellite. Europa may have an ocean beneath its frozen surface, which could indicate the presence of life. Io's breathtaking volcanic activity depicts a moon that is continually altering its look, whereas Callisto's old crater-covered surface conveys a story about cosmic bombardment that is relevant to the present day. 12 more Jupiter satellites were found by astronomers in 2021 and 2022, increasing the total number of Jupiter satellites to 92. More than 550 nautical miles from the enormous planet orbit these outer satellites, which vary in size from 6 to 2 miles. It takes almost 550 days for some of them to complete one orbit. 9 of these newly discovered satellites are interestingly rotating in the opposite direction of the inner satellites, suggesting that they have been pulled in by Jupiter's gravity. Many scientists think that these minor satellites are actually pieces of much larger satellites that were involved in collisions with other celestial bodies, asteroids, or comets. The rings of Jupiter must also be mentioned when discussing the planet's ecology. While Saturn's rings get all the attention, Jupiter's rings are just as lovely in their own understated way. The inner satellites were likely struck by micrometeoroids, which caused the formation of these faint rings made primarily of dust particles. Research on Jupiter's moons is just beginning. The Junos spacecraft was launched in April by the European Space Agency. Its intended orbital path includes Europa, Callisto, and Ganymede. In October 2024, NASA will launch the Europa Clipper mission, which will provide an unparalleled understanding of the mysterious moon Europa by completing 50 orbits around it. Jupiter, which is the largest planet in our solar system, has traditionally been considered to be the celestial defender of Earth. This attribution is similar to that of an older sibling. It was often assumed that the enormous gravitational pull that our planet possessed protected it from any potential threats whatsoever. Is this, on the other hand, the present circumstance? As a result of the complex interaction between Jupiter's gravitational forces, our cosmic environs are influenced in some way. According to the opinions of a few astronomers, the gravitational pull of Jupiter might potentially protect Earth from comets with extended periods of orbit. Jupiter's gravity is the primary factor that prevents comets like this one from slamming into Earth. These comets originate from a great distance beyond our solar system. If Jupiter were not in the way, these comets would collide with Earth a great deal more frequently, possibly even on timelines that date back millions of years. The collision that occurred between Jupiter and comet Shoemaker-Levy 9 in 1994 is just one example of the historical evidence that supports Jupiter's protective role. The dark scars that have been left on Jupiter's surface are a somber reminder of the destructive force that such celestial giants possess. That being said, Jupiter's influence is not entirely beneficial to the situation. There are some asteroids that are being driven toward the Sun, and the massive gravity of the Earth may cause them to smash with the planet. Because Jupiter's gravitational attraction is both strong and dual, there is a fine balance between the two extremes, providing some protection from faraway comets and increasing the danger from closer asteroids. In 1770, the comet Lexell came perilously close to Earth, illustrating this hazard. Because of Jupiter's gravitational pull, this comet has changed its orbit and is now heading straight for Earth. Thankfully, after 2 orbits around the Sun, Jupiter's gravity sent it whizzing back outside the solar system. Understanding Jupiter's role has become even more complex due to recent simulations. Jupiter has long been thought to reduce the likelihood of cosmic collisions with Earth, but new research suggests the opposite. The fact that Jupiter is diverting comets from beyond our solar system at the same time raises the possibility that it is guiding asteroids and comets in our neighborhood toward Earth. A remarkable example of the complexity is Jupiter's dual function as both a protector and threat. Despite the fact that Jupiter's gravity is quite impressive, this is not the only thing that makes the planet famous. After having the opportunity to observe this planet, you will unquestionably have no trouble recognizing it. The universe can be thought of as a fascinating patchwork of splotchy patterns that consist of multiple colors. There are actually frozen clouds of water and ammonia floating in an environment composed of helium and hydrogen, and each of these clouds has its own unique cyclonic pattern. The whirls and streaks are due to these clouds. There are a number of them, one of which being the Great Red Spot, a storm that has been raging for hundreds of years and is enormous in comparison to the Earth itself. Since quite some time ago, scientists have been captivated by the lightning that occurs on Jupiter. From a theoretical standpoint, clouds on Jupiter are composed of both water and ice, in contrast to the situation on Earth, where lightning is generated when particles of ice and water clash. Jupiterian lightning has been hypothesized, and the photos taken by Juno showing optical flashes and huge cloud swirls close to Jupiter's north pole lend credence to this theory. The storms that occur on Jupiter are remarkable from both an aesthetic and a scientific standpoint. There is a significant relationship between the presence of water and ice in clouds and the creation of lightning on the sky. An electrical charge is generated when ammonia vapor and water ice crystals come into touch with one another, which results in the production of lightning bolts. This flow is further complicated by the presence of mush balls, which are sticky and viscous clumps that descend to the surface of Jupiter and transport ammonia to the lower atmosphere beneath the planet. Stable storm rings surround Jupiter's north and south poles. The North Pole is encircled by 8 storms, whereas the South Pole is encircled by 5. There seems to be an endless supply of these storms, each with a circumference of around 500 meters. Why these storms maintain a specific count and how they interact with one another remain mysteries that scientists are still trying to uncover. The multicolored bands seen in Jupiter's clouds are more than just an aesthetic aspect. They reveal intricate processes occurring in the planet's atmosphere. Swirling streaks on Jupiter are the tallest clouds, which are composed of soot-covered frozen ammonia crystals. The planet's atmosphere is constantly changing, and these streaks and swirls show that. The utterly chaotic and complicated environment of Jupiter is beyond our comprehension. This gas behemoth has an unfriendly environment with winds over 400 miles per hour and temperatures several hundred degrees below zero. But the question still stands, could its thick clouds conceal hidden places where life in some unfathomable form flourishes? But scientists and researchers are intrigued by the unknown, so they are looking beyond the gas giant to the intriguing moon Europa. Subterranean oceans warmed by Jupiter's gravitational pull lie beneath Europa's icy surface, concealing a wealth of mysteries. It is possible that this secret ocean has all the conditions necessary for the existence of microbes. But because the unknown fascinates scientists and researchers, their attention is being directed away from the gas giant and toward the fascinating moon Europa. Oceans warmed by Jupiter's innards reside beneath Europa's icy surface, and each has its own mysterious gravitational pull. Some have speculated that this hidden sea contains all the ingredients needed for microorganisms to thrive. Jupiter will always be a mystery to scientists because of its enormous size, powerful magnetic field, and complex atmosphere dynamics. Which current missions, though, are uncovering the mysteries of this enormous planet? The Juno mission, which was launched by NASA in 2011, is now conducting in-depth explorations of the planet. Research on Jupiter's composition, magnetic field, magnetosphere, and atmosphere is its principal objective. Although it was previously known, recent Juno results confirm that Jupiter's metallicity is not consistent. A complex history is hinted at by different metal concentrations at different latitudes. This diverse distribution of heavy metals can shed light on the planet's origins and creation in new ways. Once hidden from view, Jupiter's magnetic field is now clearly visible thanks to the Juno spacecraft's magnetometer. Unexpected intricacy like the Great Blue Spot around the equator was one of the unexpected results. Through its journey through Jupiter's magnetosphere, the spacecraft exposed the planet's dangerous radiation belts and the regions with the highest radiation concentrations. Through its close approaches, Juno has captured breathtaking photographs of Jupiter's atmosphere, revealing features such as the renowned Great Red Spot, and recently found cyclones near the lunar poles. The microwave radiometer on board the spacecraft conducted in-depth atmospheric measurements of Jupiter, illuminating the planet's atmospheric storms, lightning, and colorful cloud bands. Scientists are still learning new things about Jupiter. The Southwest Research Institute's Scott Bolton, who is in charge of Juno's mission, states that the spacecraft flies past Jupiter every 53 days and receives a deluge of data. Whatever you look for, you'll find it. In 2025, or until the spacecraft's lifetime expires, Juno will keep on its voyage with an extended mission. With its recent enlargement, Juno is now poised to become an explorer of the entire Jupiter system, including its rings and satellites. It has plans with 3 of Jupiter's most fascinating Galilean satellites, Europa, Ganymede, and Io. Concerning Juno, though, what does death imply? Yes, the phrase describes Juno's last descent into Jupiter. Deciding to complete its exploration mission without inadvertently contaminating any of Jupiter's satellites, Juno will undertake a controlled drop towards the planet. Death dive is an appropriate way to wrap out a mission that has helped us gain a better grasp of the gas giant and the intricate system it possesses. In its last act, Juno will send data down as it plunges into Jupiter, the deepest planet in our solar system, completing our understanding of the celestial body. Future missions to the Jupiter system, such as Europa Clipper, NASA, and Jupiter Icy Moons Explorer, will use Juno's data to further their aims. The Juno spacecraft will accomplish many of the scientific objectives of the upcoming Io exploration mission by studying Jupiter's volcanic satellite Io. Even after Jupiter absorbs Juno's final echoes, the mysteries of this enormous planet will keep calling out. Behind its ominous clouds, what mysteries lurk? When the next missions launch, what will they find? The adventure is only just starting, and the universe grand and inquisitive is waiting. A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.